Hi guys, today we're going to do trigonometry, identities and equations. All right, finally we're going to do some questions here. First question, let's have a look. Obviously in the exam, they're not going to tell you compound angles. You'll have to know what to use. So given that x, the angle is between 0 and 45 degrees. Now this is a proof question, so be very careful about this proof. That left-hand side equals right-hand side, obviously. Because it's a tan pi 4 plus x, I'm going to use the formula tan a plus b. Remember that one? So I'll go tan a plus tan b all over 1 minus tan a times tan b. Okay, that's the formula we have to use. Instead of a and b, I am going to just put pi on 4 plus x. And then using the formula, I'll put a 4 pi on 4, b 4x minus 10 pi on 4, 10x. Now, we know that 1045 is 1. So that's going to be 1. That's going to be 1. So it'll be 1 plus 10x over 1 minus 10x. Now do not cancel them out. They're not the same. Now proving was to make this, our right-hand side was cos x plus sin x all over. There's a cos x minus sin x. That's what we have to prove. So this was left-hand side. So we have to make it something look like cos and sin. At the moment, we got 10, which is great because we can change this in terms of sin and cos. Okay, oops, minus sin x, cos x. Excellent. Now we need to make a common denominator as cos x plus sin x, and then this becomes cos x is my common denominator, so it'll be cos x minus sin x, and I can cancel this out because the bottom one will flip over and they can cancel. So therefore what I have left is cos x plus sin x all over cos x minus sin x, which is same as the right-hand side. Yahoo! So that would be left-hand side equals right-hand side. Excellent. So we just proved that. Okay, another one, trig equation. Now this is HSC 2021 question. So let's have a look at that. It says factorize or otherwise solve it. Now this is not a proving, so you will have to have values. You're solving equations. So let's have a look at that. All right, so this is what we've got, and we have to factorize this. I would do just factorizing by grouping, really. I will go with this 2 and this 2 and see what happens. So what's the common factor here? 2 and sine square x. If I take that out, I'm left with the sine x plus 1 minus, I'll take the minus out, and then plus 1. I'll look at that. Now I can see another common factor there, which is sine x plus 1. So what I'm going to do is put sine square x minus 1, and then I'll put that common factor here equals 0. So one of them has to be, 0 or both. So I'm going to separate these. 2 sine square x minus 1 equals 0, or sine x plus 1 equals 0. Now, this is a boundary angle. So I'm just going to sketch this sine wave here. So this one is sine x equals minus 1. Okay. So the domain is obviously 0 to 2 pi. So I don't have to worry about any other wave, just one whole full period cycle. Okay, so which one will have -1? 3 pi on 2, okay? X will be 3 pi on 2. There's only one because it's only 0 to 2 pi. I can't go any further than that. Now, this is interesting one. It's got square in there, which means it's all going to be all 4 of them. So you will have 4 solutions on this side and a 1. So all together, you will have 5. 2 sine square x equals 1. Sine square x equals half. And if I change that to cancel the square, it'll be plus minus 1 over root 2. So it's going to be pi on 4. So the x will be pi on 4 for first quadrant. And then second quadrant will be pi minus pi on 4. Third will be pi plus pi on 4. And a fourth quadrant, 2 pi minus pi on 4. Now, that equals pi on 4, 3 pi on 4, 5 pi on 4, 7 pi on 4. Okay, so we got all that with this. Okay, so what I'm going to do, I'm going to write it in order. You don't really have to in an exam if you're in a hurry, but it's nice to put it in order. But sometimes you won't be able to think properly in the exam. So that 3 pi on 2 belongs here and 7 pi on 4. So these are my solutions. Next question. So we've got to use double angles now. It's not in a pi form, so we can just use the degrees. So that's okay. I've got 2 different trig ratios, so I'm going to try to make it into as simple as possible if I could. Now, its problem here is this is sine 2x, so I don't like that. So I'm going to go to 2 sine x and cos x. Okay, that's not too bad. And also, I don't like the tan x, so I'm going to make it into 2 sine x over cos x. Okay, so let's see, 6 sine x cos x equals 2 sine x over cos x. But then I'll times by cos x on both sides. I'll have 6 sine x cos square x equals 2 sine x. And I'm going to move this one, sine x cos square x minus 2 sine x equals 0. 2 sine x is my common factor. And I'm left with 3 cos square x minus 1 equals 0. All right, so I've got 2 cases. 2 sine x equals 0 or 3 cos square x minus 1 equals 0. All right, sine x equals 0. Now, this is a boundary angle as well. Which one will give me the 0 as my roots? So that will be x equals 0, 180 degrees, and 360 degrees. 3 cos square x equals 1, so to be cos square x equals 1 over 3. And therefore, cos x equals plus minus 1 over root 3. So it's all 4 quadrants. The solution's coming from our cos inverse 1 over root 3 principal angle, 54.7 degrees if you put in your calculator. But it's a 4 quadrants, all of them. So therefore, we will go 54.7 and then 180, take away 54.7 and then 180 plus 54.7 and then 360 minus 54.7 degrees. The answer should be 0, 54 points. I'm writing it in order because there's a 4 in here and there is 3 here. So we're going to get 7, right? 1, 2, 3, 4, 5, 6, 7. Excellent. Next one. Okay, this one is showing using double angle. Which one will be the most problem one for us? I think this one. So I'm going to work on that to make it simple as possible. So we're going to use the double angle here. So obviously I'm going to go with 2 theta plus theta. It's not too bad. And now I'm going to expand this one. And 2 sine theta and cos theta. So it becomes cos square theta. Yeah. And then plus, I want to make it into all sine. I'm going to use cos 2 theta equals 1 minus 2 sine square theta. Put 1 minus 2 sine square theta times by sine theta. So, and also, while we're doing it, we can change that. Square theta, I can go 1 minus sine square theta. So I'll go 2 sine theta, 1 minus sine square theta. This way, everything will be in terms of sine. So that I'm going to just expand this one. Okay. Minus, don't forget the 2. Now let's have a look. Okay. Minus 4 sine cube theta plus 3 sine theta. That was 4 sine 3 theta. So I'm going to put it all together in general form. So I'm going to move this one to here. Okay, so we got that far. Looks good. Now, I'm just have to compare the first term here. I am going to divide it by 4 and the whole thing. So when I do that, I will get 3 over 4 sine theta plus, oh, look at that. Just going to do that, equals 0 as required. You don't have to say as required, but it's nice to say it. Next one. So second part is that by letting x equals 4 sine theta in the cubic equation, show that. Okay, so this is related to the first one. So to show proof sine 3 theta equals half. So I'm going to substitute in. You get 64 sine cube theta minus 48 sine theta plus 8 equals 0. And then I'll divide it by 64 sine cube theta minus 3 on 4 sine theta plus 8 over 64 equals 0. Now from previous one we had, okay, so we can equate this and saying that will be equal to that. Sine 3 theta over 4 equals 8 over 64 times by 4 would be sine 3 theta equals times by 4, you will get 32 over 64, which is half as required. We just showed that. Okay, next one. This is a product to sums, but with the formula it doesn't have a 2 in front. The expression we had from the question, it was 2 cos 75 degrees cos 15 degrees, right? So equals, so I just times by 2. When I do that, half becomes 1. So what I'm going to do now, I'm going to put, remember, A is 75 degrees, B is 15 degrees. So I'm going to put that in, 75 plus 15 plus cos 75 minus 15. Okay, so that becomes cos 90 plus cos 60 degrees. Now, what's a cos 90? I mean, you can use calculator, obviously, but that's a 0. And what's a cos 60, guys? Remember your exact ratio? 30, 60. So sine cos 10, half, 1. So cos 60 is half. So the answer is half. Next question is the T formula. So what I'm going to do is, so from here, okay, so I'm going to put that in a T form. So sine T will be 2T over 1 plus T squared. Cos will be 1 minus T squared, 1 plus T squared plus 1 equals 0. Okay, that's not too bad. 2 2t plus 1 minus t squared, 1 plus t squared. I'm just going to move this minus 1 there. And times by 1 plus t squared, will be 4t plus 1 minus t squared equals minus 1 plus t squared. Okay, so that will become 4t plus 1 minus t squared. I'm going to move this one. This one becomes minus 1 minus t squared, but I'm going to move them to all here. So it becomes plus 1 plus t squared equals 0. And that cancels out. So 4t plus 2 equals 0. And then you divide it by 2. 4t equals minus 2. Therefore, t equals minus half. Now that's not all. T was x over 2 equals 10 inverse negative half. Now that negative is not really value, it's which one? Where the 10 is negative, they're here, third, second, and fourth. So okay, you will get 306 degrees and 52 minutes because to the nearest. Now, problem is we automatically didn't think about the 180 degrees, but 180 is in that domain, so we need to check, make sure it's all included. Now we have to check if 180 degrees is a solution or root. It can be, you never know. So I'm going to put that into formula 180 plus cos 180 plus 1. Now, if this satisfies, then our 180 is a solution. So let's check. So that is 0 plus this is minus 1. So that's correct. So therefore, complete solution is x equals 180 as well as 306 degrees and 52 minutes. Make sure you check 180 at the end. All right, next question, auxiliary angle. By expressing root 3 sine x plus 3 cos x in the form a sine x plus alpha and solve it. Do this first and then solve. So two things we've got to do, and that's why it's 4 marks. Now, I'm going to use formula. So I'm just going to write formula here. And then alpha is 10 inverse b over a. So I'm going to use that to solve it. With that expression that we got, a is root 3 and b is 3. Okay, so I'm going to find a will be root 3 squared plus 3 squared, 12. So that's what? 3, 4. 2 root 3. Okay, so 2 root 3. Alpha is 10 minus b over root 3. What's a 3 root 3? That's 3. We rationalize denominator. So it becomes, which angle has 10 something is root 3? 60 degrees, which is pi over 3. So we have this and this. Therefore, we can put that into in the form. All right, this is not the answer. This is part of it. And then we have to solve it. Solve it when that whole thing equals root 3. Okay, so instead of using these, because you've got 2 unknown, I'm going to use these. Because that looks much simple and easier. Then I divide it by 2 root 3 on that. Sine x plus pi and 3 equals root 3 and 2 root 3 becomes half. Excellent. X plus pi on 3 equals inverse sine and half. Okay, which one has a half? So it's a 30 degrees. Pi on 6. Which quadrant is that? It's positive, so it's going to be first and second. X plus pi on 3 equals pi on 6. And then pi minus pi on 6. And then I'm going to go around one more. Okay, so this was 2 pi minus theta. So that when I pass it, the force and go to the next one, it'll become 2 pi plus theta. Okay, and the next one, when I go to there, becomes 3 pi minus theta, and keep going 3 pi plus theta, and the next one will be 4 pi minus theta, and keep going. So if I go one more time, I'll go like this. Okay, so what would that be? 5 pi on 6 and 13 pi on 6, whatever. And we got minus pi on 3. So x equals pi on 6 minus pi on 3. And then 5 pi on 6 minus pi on 3. And then once 13 pi on 6 pi on 3. Okay, so what do we get? We get interesting stuff. Here, it'll be minus pi on 6. And that'll be pi on 2. And that'll be 11 pi on 6. Now, if I did it one more time here, just curious. So if I did that, 17 pi 6 minus pi on 3. Now that becomes 5 pi on 2. Now our domain was 0, x, 2 pi. Okay, so that is not on. That's wrong because it's a negative. That's okay. That's okay. Now this one, it's like 2.5 pi, isn't it? So it rounded already twice and then a bit more. So it's out of boundary. So the answer is pi on 2 and 11 pi on 6 only. Or just make sure you check your domain. All right, the last one is finding general solution. Sometimes they're not going to tell you find the general solution. They'll just find the solution for it. So you have to realize, okay, there's no domain. I've got to do general solution for this. And obviously that can be changed to sine x and cos x equals cos x. And I'm going to move that because I have to solve it. Minus cos x equals 0. Now do not ever do this and then make it into 2 sine x equals 1 or something. Y is not good because you can't really get rid of the x here. So be very careful. That's no. So this, factorize it. So when I factorize this, I will get 2 sine x minus 1 equals 0. And that will be cos x equals 0. 2 sine x minus 1 equals 0. Now that is my boundary angle. Remember that? So that's here and here. So x becomes, what is it? Pi on 2 and 3 pi on 2. And then this one, I will go sine x equals 1 on 2. And also it's a plus, so to be first and second. X will be sine minus 1/2. Now that's what? Pi on 6, isn't it? So we've done that previously. So I'm going x equals pi on 6. And I think from my memory, for 5 pi on 6, 11 pi on 6, 17 pi on 6. I think that's how far we went. Okay, so we got these. Oh, actually, we can keep going. 5 pi on 2, and 7 pi on 2. Keep going. All right. So we can't keep writing all this. So we've got to stop somewhere and just put general formula. Now, if you look at this, don't rush into it, because this is as cosine and this was a sine. So you might think, okay, I just have to add 2 pi n, but it's not, because when it's a boundary angle, you have to be careful. So when you look at the pattern, it's going up by pi, okay? So it's not going up by 2 pi. So don't think it's automatic when it's a boundary angle. So you have to be careful with that. So my solution would be pi on 2, plus pi n, or n pi. It goes up by pi. And here, we can't really see the pattern happening here. It's going up by 2 pi. Pi on 6 plus 2 pi n for the first quadrant, or second quadrant, I have to go 5 pi on 6 plus 2 pi n. Okay, and you have to mention n is any integer. So therefore, A could be pi on 2 plus pi n, or pi on 6 plus 2 pi n, or 5 pi on 6 plus 2 pi n. So you got these 3 general solutions for it. Okay, so that's it. All right, good luck and happy studying. Bye.